Our first presenter is Mr. Ader from Ankro tunnel. Please.
Honorable audience, ladies and gentlemen, my name is Ader, as you see here, and obviously I am really late to reach the train, which has the direction finest link, but it already left the platform. But I am quite sure, as trains always, after one train, the second one will arrive. And what I actually know, the second one is even cheaper and also quicker, faster one. And that's why I am trying to highlight some points of submerged floating tunnel, as you see. It was question, it is submerged floating tunnel. And in the other words, it is called Archimedes Bridge. Who knows? And why prefer the submerged floating tunnel? Why? First of all, it can be much shorter than usually bored on the ground tunnels. I have some calculations here. If we get from Paljassaare, it's a second option, to Kirkkonummi, it will take 59 kilometers. And from Viimsi, nearby Muuga, not from the top, it takes 59 kilometers to reach the other shore. And from Viimsi-Püünsi to Kirkkonummi, green one, it will take only 52 kilometers. And of course, this proposed tunnel is much longer, and this real tunnel is about 90 kilometers. It's general layout of the submerged floating tunnel, shape of layout, and it's anchored to the bottom, tops on the ground, and it lays below the water. Yeah, about 40 meters, but why not completely near the seabed? And general view, it's artist draw it. We can see this from concrete, reinforced concrete modules, which creates two separate ways, one to Finland, one back, and for both passenger traffic and cargo traffic, the separate tunnel or it's from maintenance and also for escape matters. And this tunnel is to fight against buoyancy. It's anchored to the sea bottom. I can a little bit explain what's the difference between submerged floating tunnel, it's here, immersed tunnel, it's on the seabed, and rock tunnel, it's generally planned here now. And all of them are, of course, are underwater tunnels. it's always is danger to be overflowed. And why underwater tunnels are not well known yet. The first underwater tunnel was built over 4,000 years ago, but floating tunnels are much more recent. Even bridges are most common structures used for crossing water bodies. Tunnels in the water are by no means new in civil engineering. This is because it seems very tempting to replace the difficult land digging, especially if tunnels need to be dug into rock. But water environment does not need digging. It's clear. Since about 1900, more than 100 immersed tunnels have been constructed. Of course, those are short ones, usually. The main problem is in using underwater tunnels is complicated construction, because it is difficult to connect tunnel parts underwater surface and keep them watertight, and it makes such building very expensive. Since 1923, the potential of SFT has been recognized in Norway as a way to create a practical highway across fjords. This need for shorter, shallower tunnels for a number of fjord crossings has led to detailed investigations and field tests that still continue today. The first of series of straight crossing symposia in Norway began in 1986, and there's many. The fifth was in 2009, and in which SFT have played an increasingly greater part. Sorry, here is no Norwegian ones. Probably they can explain. What about building such concrete immersed tube? Those are built in dry dock with usable technology, and after that filled with water, closed tops, and transported. Its view from this, it's in 2015. But it's, as I said, it's immersed tunnel. It's a little bit different. To compare Drogen tunnel cross-section to 4 stores house and 12 meters anchored tunnel, what we actually anchor tunnel is proposing. Some of patents for submerged floating tunnel have taken, and for 1891 you have seen one of them, the US ones, and it's from 1925, the second one. It's turned a little bit. And the last from 1969, it's something like we are going to propose. And there's quite difficult construction in intersection. But the technical challenges of building SFT is, of course, the need to prevent resonance vibrations and movements being induced into the hollow tube, as well into the anchoring tethers under different hydraulic and dynamic loads conditions. The practicalities of fabricating and placing of the tube elements, installing the anchor systems, and realizing the landfalls AZZ. And now, maintenance and repair of submerged infrastructure, addressing the highly improbable but perhaps possible event of submarine or sinking ship colliding with a suspended tube. Of course, anchoring, someone lows anchor, to the tunnel. That's the problem. And in general way, the public perception and operation safety, how to gain confidence of the public and assure the safety of the infrastructure of the clients and the insurance industry. Known ways for SFT construction. I have to rush. I will jump because time scale is very tight. And third possibility is to use a tunnel building connected to the tunnel and special mobile watertight docks. It also used. But in any case, much attention is required for tunnel anchoring, and there can be used piers or tethers anchors. And the last one, the best way is to submerge tunnel like gas pipeline. Gas pipeline, but how to do this? It's different to submerge steel tube 2 meters diameter or 10 meters or more concrete tube. It's a question. And some of known future projects of submerged floating tunnels. I am explaining that I am not very fantastic here. The planet in Norway, but on the floats, it's anchored to the seabed, and even transatlantic tunnel is proposed. You can see transatlantic from UK to America. So that's ideas. Conclusion. The submerged floating tunnel will set up, not full presentation, but submerged floating tunnel will set up new trends in transportation engineering, and which shows with advances in technologies that will reduce the time required for traveling. It's always known. For wide and deep crossing of submerged floating tunnel may be the only feasible fixed link, replacing present-day ferries and providing local communities with new opportunities for improved communication and regional development. And especially if can be built 3 times cheaper than underground tunnel. It's a point. And now proposed by Ankurtalon novel approach, how to build SFT effectively. First, to make tunnel from modules and modules to compile from prefabricated sections. Second, to compile modules directly on the mounting platform. And third, to submerge tunnel with dry methods continuously using effective anchoring system. And such prefabricated parts of module. 5 parts, 2 sections to connect, 2 connected, 3 connected. First section adding 4 sections already, 5 sections together, 6 sections together, 8 sections, and module with inner walls. It separates, makes 3 different tunnels in one. Important thing is sealing of those modules between each other. For this is used O-ring, like car tire with pressure. Its section is. And in real scale, it could like this, in half meter of, and connecting modules. And important thing is to understand how to bend the tube. It's important to understand this. This flexible sealing makes possible it to adjust upper side closer to each other, and it makes necessary angle to submerge from the platform. And the idea to see this, it's like this. And its section here is shown. It's this pressurable sealing, O-ring, and so on. By the way, it's useful to cover this concrete construction with plastic skin to additional watertight. It's cross-section, and it's important things to see here is this it's escape capsule or module on the up side of passengers can be reached to this and disconnect from the tunnel and flow up to the surface. It's of course not to everyone. It's about probably 2 kilometers necessary. It's novel proposal. Its anchoring system is also thought a little bit at it will be anchored by pulling continuous rope or wire. Its idea. And full picture is like this. This escape module is shown here. People are sitting inside, we can see. and modules with this escape module. Let's separate. It's some calculations I done. I will not stuck on every detail, but generally I took this building precast concrete price about 500 euros per ton. It's for calculation. It gives this tunnel pulse and montage only about 2 billion euros. It's not very expensive. And for this, it is a platform we need for building it, and platform with this anchor drilling tower. This conventional petrol boring tunnel. It's placed on console. It can move far from ship. It's picture from this, and it's. I can show that it's already used with these 4 legs to stand in shallow waters. And arguments in support of floating tunnel is important. The future project based on the modern technological capabilities and needs, which in the successful launch also includes application in the rest of the world, with a high-tech line for the production of tunnel parts to remain in Estonia and Finland. Worked out know-how and successful patent rights would provide long-term profits. Second one, can be combined with Hyperloop technology and will make positive media. Such novel construction comes with the idea of Rail Baltic and makes really possible to finish tunnel construction simultaneously with Rail Baltic and to save resources. As I said, it's faster to build. Our own labor and engineering staff can use and thus earned during the construction and during the operation, the tunnel money will stay here in Estonia and Finland. Finland experience and shipyards can be used for floating platform design and building. After successful first project, such production can be sold for future projects around the world. Investments to the northeast of Estonia, there is good possibilities to create this module parts. All resources are available. It will remarkably reduce local unemployment and thus also will reduce national security risk. It's political question. And I expect also it can support Saaremaa fixed development two-way road tunnel over Kesulaid, 3.5 plus 3 and 5 and 4 and 5 kilometers. As it was my presentation, we saw what is submerged floating tunnel or Archimedes bridge upside down. You can see here, bridge upside down. And thank you. And this is built by my own hands, bridge. My wife, my dog. Thank you.